This video is over proportionality theorems and your essential question, how can I use parallel lines to solve for missing links? So we're going to talk about 3 proportionality theorems, and they're on this second slide. The first one states, if a segment cuts the sides of a triangle into 2 equal parts, then the segment is half the length of the base. So let's take this a step at a time. So if a segment, so this segment right here is talking about this segment right here. If it cuts the side of the triangle into 2 equal parts, so that means that this part and this part are equal, this part and this part are equal, then yi will be half of em. So if you look below, say if mi is congruent to il, and ey is congruent to yl, and em equals 15, then what would yi be? Well, since we know these are equal and these are equal, then yi has to be half of em. So yi will equal 7.5. So we're going to use that theorem to do example number 1. Okay, so example 1, it asks us to find x and y. So we have to look at our problem here. So these y's I have are both on the sides, and we know since they have the little dash marks, then those are going to be equal to each other. So in this particular problem, we're going to solve for x and y separately. So first, let's find out what y is. So if those are equal, then let's set them equal to each other. So I have 4y plus 6 equals 2y plus 18. Subtract 2y from both sides. 2y plus 6 equals 18. Subtract 12 from both sides. 2y equals 12. Divide off the 2, and y equals 6. So that's our y. And now for our x, we have this side and this side. Well, if you remember the theorem from just a minute ago, it says that if the sides of the triangle are congruent, so this side is congruent to this side, and then since these have 2 lines, those are congruent as well. So that makes 4x minus 5 half of x plus 11. So let's solve for that. So we can write 4x minus 5 equals half of x plus 11. So I have 4x minus 5 equals 1/2 x plus 5.5. So let's add 5 to both sides. So I have 4x equals 1/2 x plus 10.5. And then now I can subtract 1/2 x from both sides. So now I have 3.5x equals 10.5. Now I divide off my 3.5, and x equals 3. So x equals 3 and y equals 6. Okay, now let's go to the second theorem. If 3 or more parallel lines intersect transversals, so we have 3 right here. We have 1, 2, and 3. And then we have our transversals. So this is a transversal, this is a transversal. Then they cut off the transversal proportionally. So what that means is these 4 intersections that I have here, they are proportional. So if PQ to QR, DE is proportional to EF. Or I can write it as PO and DE, and then QR and EF. Okay, now let's look at the example below. So in this one, we're also just solving for x and y separately. So first off, let's just solve for y first. This is the first one on top. So for these, we're setting up a proportion. So we can do it like either one of the ways it showed us at the beginning. So I can do y over 2y minus 5, and then 3 over 4. I'm not going to deal with the x's right now because I'm only solving for y. So y over 2y minus 5 equals 3 over 4. Now to solve, I cross multiply. So that leaves me with 4y equals 3 times 2y minus 5. 4y equals 6y minus 5. Subtract 6y from both sides. I get negative 2y equals negative 5. Divide off the negative 2. So y equals 5 over 2, or 2.5, however you want to simplify it. Okay, so that's y. Now for x, we're going to do the exact same kind of proportion. So we're going to not worry about the y's. We have x over x plus 3 and 3 over 4. Let's make a little division here. Okay. So we have x over x plus 3 equals 3 over 4. And then now cross multiply. So I have 4x equals 3 times x plus 3. And 4x equals 3x plus 9 minus my 3x. And x equals 9. Now we're at our last theorem. So if 3 or more parallel lines cut off congruent segments, and you see how these have little dashes here, so all 3 of those segments are congruent on one transversal. So these are the segments on this transversal. Then they cut off congruent segments on every transversal. So this is our second transversal. So it means that this side, and this side are all congruent. Not necessarily congruent to RS, ST, and TU, but congruent to each other. So we can say that MN, NO, and OP are congruent to each other. Okay, and then we'll do the last example for this problem. So in the previous theorem, it says that if I have 3 or more parallel lines, so first we got to make sure, in order to use the theorems, that our conditions are set. So we have 3 or more parallel lines, well, that's check. And then on one transversal, all 3 of the sides have to be congruent, check. So if that's all true, then we can say that all 3 of these sides are congruent as well. So if that's the case, then x plus 1 and 2x minus 5 are congruent to each other. So our question says find x in all segment lengths on the left side. So we're trying to find all these segment lengths. So since they're congruent, they're all the same, we only have to do one equation. So let's set those equal to each other. 2x minus 5 equals x plus 1. Subtract x on both sides. X minus 5 equals 1. Add 5 to both sides, and x equals 6. So since x equals 6, then we can plug in x for 6 on these sides. So x plus 1, that would be 6 plus 1 equals 7. And if you want to check yourself, you can go ahead and plug in x to the other one. You don't have to, but 2 times 6 minus 5, so that's 12 minus 5 equals 7 as well. So all the segment lengths are 7. Okay, that's the end of this video, and I will see you next class. Bye.